Hello everyone and welcome to our May 2022 event. So today we'll have Paul Dragoonis talking to us about the future of continuous delivery. And then at 8 we'll just hang around for a chat. Our platform is Big Orange Heart, and their aim is to support and promote positive well-being and mental health within remote working communities. So let's get started. Hi Paul.
Hi.
How you doing?
Good.
You ready?
Yeah.
Let's go.
Cool. Is it working okay? Can you see the screen? Cool. All right then. So, I'm curious. Where is the chat? Like the actual public chat? Is there a public chat for the audience, or is it just private only? Okay, figure it out. Thanks for coming to my session. This is my talk's the future of continuous delivery. I'm Paul. I represent the CD Foundation, and I represent myself. So just a quick, brief introduction: who I am. Who am I? I'm an open source contributor. I'm a member of the Jenkins project, and I'm a member of the PHP core team, PHP web team, and PHP Fig standards body founder and member. I create standards, software engineering standards on the web, and I'm also a conference organizer, Organise Scotland PHP, and I'm a member of the CDF, which is part of the Linux Foundation. I professionally work as a consultant, or have in the past worked as a consultant, ranging from CTO to head of engineering to principal architect and engineer. And I do lots of QA and DevOps and kind of all the things software related. And that means I spend a significant amount of my time in CI/CD land, specifically rolling out CI/CD solutions and embedding continuous delivery processes into companies, mainly in the private sector, public sector companies like Barclays and public sector government departments as well, big projects. The agenda for this talk is around we'll break it into a few sections. So we've got kind of a little bit of a historical context of how we got to here in present times. So just kind of what traditional stuff looks like and kind of a little bit of a journey. And then there was an innovation trigger. And then I'm going to showcase a few innovations that we have right now to use, and then where these innovations are taking us, and therefore what to expect also from the open source community going forward in the CD landscape. If there's any questions, you can drop them in the chat. At the bottom of my slides, you'll see a little letter number 4 here. It's a slide number. So if you've got a question, don't have to wait till the end. You can just drop the slide number in and ask a question if you've got any at all. So where did we start? So CI/CD and kind of pipelines, or whatever you want to call it, has been around for since the 70s and the 80s. So it's been here a long time. So it's not really a new problem or a new solution. And this is what traditionally, up until maybe 2010, what the majority of web software looked like, just one app, and we call it a monolithic architecture. And respectively, we had one Git repo, and now we have basically one pipeline. And so a pipeline is just what is a pipeline for this model? It's just a sequence of steps, and it's very simple, sequential steps. It's very easy and kind of to build and to reason with and to understand and to also embed within your organization. And as such, these are the standard stuff like build, test, deploy to staging, and then promote that up to production. And so this is traditionally what things look like. So up until 2010 or so, life was simple, predictable, and stable. And then something changed. So the point is, like, globally, software organizations and internet companies are delivering more and more software at a rate and scale that we've never faced before. This is due to the fact of, let's say, smartphones and mobile applications having a huge kind of footprint on the web, and as such, a massive demand on the software and the scalability and all these things around the web, not just mobile smartphones, but that's a major contributor to this. And so basically, yeah, the internet is just huge compared to what it used to be, and as such, this created unprecedented demand that's created new challenges on us all, and has been hurting our organizations when we are trying to create continuous delivery solutions that need to match what non-monolithic architectures look like. So this is basically where we were and where we are now, which when we call it microservice, it's basically distributed systems architecture, right? And so we're taking massive systems and we're splitting them into small parts. This creates a number of different challenges, specifically from a kind of testing and deployment point of view and delivery point of view, because the rules were simple before. Now the rules are, or were, the goalpost moved from underneath us. So what do we do? Ultimately, the blockers and the challenges that occurred when the internet, the engineering community shifted from one to the other, and so pipeline development became really complex. Sharing code and steps between pipelines, like maybe you might have like 4 or 5 or 10 or 20 different applications or different services or microservices on the web, and they have similar pipelines. So like, how do you just write something once and then run that for all of your services whenever you've got, say, 20 Git repos or whatever, right? So you've got 20 apps. So pipeline development becomes complex. The dependencies between your services becomes complex. There's loads of questions that opened up, right? And as such, there became no rules, and building pipelines, CI/CD stuff, became a bit of the wild west at that time, because there was no real leader or way to do something, because traditionally most everybody in the world is just using Jenkins, and they have sequential pipelines, and it makes sense. So we transitioned, but the CI/CD sort of strategies weren't really there already for the community to pick up. So what happened next is then the trigger of innovation occurred. So the first trigger of innovation that occurred was private companies led the way for kind of case studies on how they are doing CI/CD solutions and deployments for microservice architectures. So companies like Weaveworks and CodeFresh would publish blogs. People would look at that, copy it, try to adapt it, and put it into their organizations. And it was a lot challenging for people to do that with existing open source technologies that were traditionally monolithic based. And so private companies like Circle CI and Bitbucket and GitLab created their own closed source proprietary general purpose solutions to allow you to, again, do stuff, and using private sector money to innovate on the solutions very quickly and immediately to try to give us some kind of solutions that meet our what we need from kind of continuous delivery solutions. So that was good. An innovation occurred, and we got somewhere. The problem with general purpose solutions is that you need to model your organization's processes around the tool rather than model the tools around your organization, because they're general purpose and they only bend so much, and you can only configure them in predefined ways that don't really reflect your organization or organically, naturally. So they're good, but they have a lot of their challenges as well that they bring. So that's the private sector trigger of innovation that happened. And then the next thing that happened, which takes us up to, say, 2014, 2015, which is the open source community caught up, reflected on what's happened. They reflected on the innovations that the private sector had done, like Bitbucket, Circle CI. Later on, kind of GitHub Actions is also a reflection and innovation, but they're not open source, of course, right? And that's where we were. Everybody was open source, kind of Jenkins land stuff, and then now we're kind of going full circle on this again, whereby the open source community were able to look back and reflect and design solutions that actually are fit for purpose and reflect how we work today and how we're going to be working going forward, which is, I guess, very different from how we historically were working. The innovation specifically is in a cloud native focus, which means it runs, say, as a containerized, something as a container. We've seen all the Docker stuff moving around, and then ultimately moving it towards Kubernetes. So Kubernetes being the main containerized, platform for running and managing container workloads. And so that's what it means to be cloud native, because Kubernetes can run on any cloud platform. So if you build a container once and you stick a Kubernetes file around that, you can drop it into any Kubernetes cluster on any cloud, and that's what it means to be cloud native. Now, specifically, what I mean by Tecton here is, in my opinion, Tecton was the first major project to be recognized for its innovation in the continuous delivery space. And just to give you an example of what Tecton is, but it is basically, it's a platform agnostic, cloud native, containerized thing that runs on any hosts, on any container, any platform, any cluster, basically, and you define your pipeline. So there's no Jenkins, there's no like fancy UI, there's no proprietary company. You basically just use YAML files and other configuration files, and you just map out your your delivery processes, your pipelines, and the tasks and steps within those pipelines and what they should do. It's fully containerized from the get-go, and you can spin it all up on one machine, and you can spin it up on another machine, your pipelines, and they'll just run and run and run. So that really pushed the envelope to say, hey, you know what? See all this stuff that we're getting from the private companies and what we kind of had, we're trying to achieve with the legacy, like kind of older school Jenkins stuff. We can actually do this now, and it's possible. And Tecton kind of proved that, and that's what really brought a good attention to the continuous delivery space. Now that was 2014-15. Now we fast forward to where we are today, which is 2020, 21, and 22. We have a flurry of loads of prominent projects that are leading the way in terms of kind of cloud native, specifically continuous delivery stuff. So there's a lot of information on this slide, but we'll come back to like different parts of this slide later on and explain things. So initially, our innovation occurred when we created the CNCF, the Cloud Native Compute Foundation, which is predominantly where you would hear the Kubernetes project being a major player on that foundation. But there's other projects that have joined since. One being Captain, which I'll tell you about in this session as well. So the Linux Foundation has been around for a long time. The CNCF Foundation, which is a sub foundation of that, was launched, and then now we've got the CD Foundation, which is the one I joined. So the CD Foundation is basically cloud native ecosystem projects, but with a specific focus on CD, right? So Jenkins Xci, which is the new Jenkins, cloud native Jenkins, and Spinnaker, these are examples of projects that are in the CD Foundation. These are the projects that are part of the CDF at the moment. So you've got Jenkins there, the official Jenkins project, the main one, and Tecton's in there, Spinnaker's in there, and then there's and Jenkins X, and there's a few other smaller projects that have joined as well that add value to the CD space and make things in our lives easier. And an additional innovation I wanted to cover, which is the GitOps methodology that's kind of came out of this space. This is an outcome of the innovation and shift to distributed systems and microservice architecture. So I'm just going to briefly explain what GitOps is, which is it's you get to define the desired state declaratively in Git around what the state of a service should look like. So when I say service, that's just your app, right? A container, right? Or a service on the web. You could have 2, 5, 10, 200, right? And one of the main challenges this is why, see, the traditional CD systems are not fit for purpose, is because they're all about having one artifact, one application, whereas now we have got 10. So it was really challenging to be able to track and manage which applications are running on which environments in your organization, and which versions of those applications are running on which environments. And so when you're doing change management and you're releasing new versions of stuff, it became as such it became really hard to manage and understand and track and other things. So we, as a community, we created something called GitOps, which is basically a Git repo, and it defines all of the app services on which environments and which versions of those services, basically. So when you do deployments, you'll change a container version from V1 to V1.1 to V1.2. So that's the change you're making. You've got a new version, and the main important thing that ties into this is it's not just about maintaining a text file. It's that there's CD tooling these days that is actually listening for changes into like commits or merges or whatever pull requests raised on your GitOps repository, and they know what to do when they see that change as well. So it's basically change management, but there's triggers and those things, changes on your GitOps repo chain trigger things on the CD tooling, and all your processes sort of align there. So it's a good thing that as a community we've moved to. So if you're not using GitOps, or you haven't used it, or you're looking to use it, I thoroughly recommend you go on YouTube or you go on blogs and check it out and see how you could try to integrate that into your company, into your projects. Ultimately, the target state of your applications is fixed in a Git repo, in a file, and so you can also revert commits or pull request merges, and that would actually mean that your service would go from version 1.2 back to 1.1 because you're reverting a commit. And when you do that, the tooling just listens and realizes as such, and you basically just do live rollbacks, right? And so the CD tooling understands that you've done a rollback, and it will take remediation strategies and steps to do a rollback for you safely and cleanly. So yeah, that's GitOps. And there's two tools that I will highlight on this area, which is Argo CD and Flux CD are the main players in the GitOps world. And so basically their tools come out of the box and they recommend you work in a GitOps fashion. So you kind of land on your feet at that point when you use those tools. This is a graphic around what GitOps is. So basically developers would push stuff to their repo, they get Docker builds, their CI pipeline finishes, and it creates a package repository, which could be a Docker image, right, or an RPM or something like that. And then the second step, which could happen automatically or manually, it says the little person here that says ops person. That could be a DevOps member of your team. It could also just be one of your developers, right? But it's a separate Git repo, and that's the one that contains the state of your services and the versions. And so as soon as you change that repo, then that's in this example it says Flux controller. So that's just the Flux CD tool listening and watching your repo for changes and then reflecting those into workloads and updates the workloads, i.e. updates your apps in the cloud. This is an Argo example, which is very similar. But the idea is that if your CI pipeline passes, like let's say you're merging to the master branch or whatever it is, your main CI pipeline can actually automatically push changes, commit changes to the GitHub repo for you, and basically bump that version and have a thing. So you can have it. The previous slide shows it being done in 2 steps, which is manual, but in this we can also just configure one pipeline to change the GitOps repo content, and then Argo in this case would have a polling or a webhook trigger, and that would trigger your whole deployment process. So all that visually made sense. This is GitOps, and this is kind of why we're moving forward as a community to this, because you might have one change and that change might span across 3 of your services and you need to deploy all 3 of them at the one time. So that would be one commit, right? For example, one commit onto the repo, and then it would go and trigger the three upgrades in real time as a kind of full deployment, which would, so yeah, basically, hope that made sense anyway. Here's a little tool I want to highlight. It's not specifically a CD tool. It's a Kubernetes tool, but it's actually built for developers and not rather than for infrastructure or DevOps or SRE people. So typically, it's kind of just an abstraction on top of Kubernetes, and I wanted to highlight that to developers. So normally a developer says, I want a web service, and then like a developer, you just tell kubevilla, I want a web service with some details, and like kubevilla will create all the Kubernetes resources under the hood, which is arguably like 1 to 200 lines of YAML code that you'd have to manually write yourself or at least change and stuff. So there's loads of things in Kubernetes, little building blocks that you need to actually have something that's on there and running and accessible in the cloud. So the point is that kubevilla, you just write like 20 lines of code of YAML, just telling it what you want, and it will actually go under the hood and create the Kubernetes files for you to reflect what you want. So would you rather write 20 lines of code or 200? So that's the kind of the USP that they have. And I just wanted to highlight that if you're not really, if you don't really know Kubernetes too much, or it's a bit daunting, this is a good place to start, in my opinion, is getting your stuff on the cloud. And kubevilla will help you get there. This is Jenkins X. So Jenkins X is basically an opinionated out-of-the-box solution that utilizes cloud-native technology. It can be installed on any existing Kubernetes cluster. So if you've got a cloud Kubernetes cluster, you could just say, hey, Jenkins X, go and install yourself on that cluster, and it will install itself there, and it will have all the bells and whistles that you need for continuous delivery stuff. And if you don't have a Kubernetes cluster, Jenkins X will go and actually make one for you. You just give it your credentials, like your AWS creds, and it will actually go and make a cluster for you, and then install itself on that cluster. So it's kind of like a full solution now. And it gives you like predefined environments like local staging production, and you get to configure the path to live for each of your services. For example, do you want to do manual approval to go to production environment to promote an art, like to promote one of your apps from staging up to production, or do you want to have that happen automatically? And so and so you'll get to define. You'll get stuff at the box, but you can define your environments that and your processes that kind of map and match your organization. And because it's not like proprietary software, it's fully configurable because it's open source. So you get the flexibility to basically tell it exactly what you need and extend any things that don't work the way you want them to work. So it's kind of giving back access and control to us as the software people. And it has GitOps and non-GitOps options, so it does support GitOps from the get-go. And so if you just do that from the get-go, then it will do more for you and it will be simpler. So highly recommend you check out Jenkins X on the Jenkins X website, and you've got YouTube and blog posts and stuff to see case studies and what people are up to. So I highly recommend you check that out. This is the next tool. It's called Spinnaker. So Spinnaker is actually one of the oldest CD tools that I've in this talk that I focus on. Spinnaker actually came from Netflix. So Netflix have to deploy changes across multi regions and multi availability zones, like worldwide. And if there's any redundancy or network outages or failovers, then they have to swap their traffic, change their traffic to go from one region to the other region in real time because one of the regions is broken or there's an outage or a network issue. And so it gets quite complex and really important to get right. And so Netflix did that, and then they open sourced it. Now, what happened next is the Google team took Spinnaker and they extended it further to create what we have now is Spinnaker. So ultimately, it's how Google do their continuous delivery, their deployments, and all their stuff. Now, this screenshot here is just to give you an example where you can see you've got your kind of path to live and your integration steps, your testing phases, and then you can have like manual and non-manual. So you see at the bottom it says like continue or stop button. So that's because you've configured it to say, hey, we don't go to production until someone actually presses a big red button, basically. So yeah, this is just an idea. Now, Spinnaker, you can just use Spinnaker as a CD tool on its own, and all of these tools you can just use as CD tools because they have APIs that you can just trigger things. So if you've got an existing continuous integration pipeline that's in Jenkins or GitLab or GitHub Actions or something, well, that's good. And if you want to keep it there and don't want to do your testing and integration testing and unit testing and all that, if you want to just keep it there, that's fairly legitimate and fine. But at the end of your CI pipeline, when you want to actually trigger like a CD step, like actually deploy something, then you can either go bare bones yourself, or you can try and reuse the tool, or you can actually have control and you can set up a dedicated CD tool like Spinnaker or Flux or Argo, and then just API call that from your Jenkins pipeline or your CI pipeline and just trigger an API call and just tell it what changed. Or even better, your CI pipeline commits to the GitOps repo, right? It creates a commit into the GitOps repo, and then it walks away and stops. And then these tools, therefore you don't have to make API calls to these CD tools because these CD tools are just listening for changes on a GitOps repo. And so it's fairly trivial to make a commit on a Git repo in code on your CI pipeline. So you can just push to there, and then these tools will just take over from that point onwards and look at the diff and figure out what they need to do. So you've got different options on how you either you go full CD or you just integrate with CD where it makes sense to, and you keep your existing stuff, either legacy or non-legacy. Here's another diagram around Spinnaker. So ignoring a lot of it, if you focus right in the center, you've got Spinnaker. And then on the right of Spinnaker, you've got your environments, right? Dev, staging, and prod. So you've got tooling integration as well. So on the right, you'll see like Elk Stack, logging, as well as like monitoring in Kubernetes, Prometheus type stuff. So it's a little bit, it's more sort of environmentally aware of what's happening on these live environments as well, from a monitoring perspective, because that Prometheus data will kind of feed into your Spinnaker dashboards and your Spinnaker pipelines to, help you do more stuff, right? Um, so that's just kind of, this is on the left here. This is a Jenkins pipeline, right? On the kind of creamy peach colored thing. So it's the standard CI pipeline where it does a Docker build and it runs automated tests, and then if it passes the CI stuff, then it creates a Helm chart or a chart, which is basically just a Kubernetes thing that says I'm going to tweak the version now, and then it pushes. So in this case, it's not using it. So it's got chart source repository, which is actually a GitOps repo these days. But this image is a bit before the GitOps came out. So before we had just like, again, it's just a repo with the versions of stuff, and that will trigger, right? And it does a trigger, right? So yeah, this is kind of Spinnaker is the most mature CD tool we've got, in my opinion. But it maybe doesn't have the latest and greatest stuff, but it's an absolute solid choice for an organization. There's plenty of support out there. The next project we're moving on to is Argo. The umbrella of Argo project has two main areas. It's got the Argo workflows, which is what you would call a pipeline, which is a workflow of your app. And then you've got Argo events, which is a new thing. I'll talk about that later on in the talk, this session, because that's kind of a future thing. Events and event-based architectures of pipelines. And Argo out of the box utilizes GitOps, as well as other modern best practices and approaches from the get-go. So if you choose Argo, which is a more modern tool than Spinnaker, then you can get more, you land on a stronger foot, basically. And Argo are at the heart of innovation, and they're an unopinionated solution, and allow you to kind of build out your own stuff organically to reflect your organization and how you want to work. Whereas comparing that to say Jenkins X, which is by default very opinionated and it's a full setup, then you have to start tweaking and changing things. So different approaches apply to different tools. Here's an example of Argo, whereby on the left, it's very similar. On the left, the developer commits code, it goes through a CI pipeline and updates an image repo, which is a new version of your app. And then the second part of the person is just changes config. So that could be a basic GitOps repo, right? Or some kind of Helm package thing that wraps it. It actually then will trigger a CD pipeline that will sync to Argo, and then Argo will do your environment management and put the right things in the right places. This is Captain. I haven't spoke to you about Captain yet, and this is another later innovation now. So this is very, very recent, maybe only one or 2 years now. It's been very seriously fit for purpose and production ready, and has a lot of good large companies using it. I met with the core team last week. So just getting an update from them, what they're up to, and things like that. So here is Captain, and it's actually quite cool and quite innovative. So if you haven't heard of it yet, then definitely check it out some more. It's an umbrella around the other tooling that I've showed you. So it's an umbrella around your Jenkins. It's an umbrella around your Argo and your like Spinnaker and things like that. Now, Argo and Spinnaker, they're dedicated tools. You don't need Captain, but Captain is more of a higher level abstraction for your business, which has tools that you integrate into if you want to, or Captain can do the stuff itself. So in addition to that, it has tooling around testing built into it. It understands it natively, and it also has tooling around observability and tools, and it communicates with them. And ultimately, Captain is a control plane, what we call a control plane, kind of like a command center for all of your environments and the promotion of each service from dev all the way through to production. And it just manages the full life cycle. Therefore, it manages the full life cycle of your applications and services, from feature environments and feature branches all the way through to production releases and things like that. So just briefly before I move to Captain, there's three terminology from the SRE world, the kind of monitoring world, called SLOs, SLAs, and SLIs. An SLI is a service level indicator, and it measures. It's a key measurement how to determine how available and how performant a system's being. Like, for example, the response time, how quick it takes for an API call to come back, or something like that. Or what the CPU and RAM looks like on the hardware, for example. SLOs are like outcomes, which is like how much we expect to get out of a system based on, say, a certain scalability, a certain traffic, right? Like at this level of traffic, we expect the system to be this fast or that fast, and that's and anyway, and SLAs are the legal contracts that are basically what happens if the system doesn't meet an SLO, what happens if the system's down, what happens if the system's too slow, people can't pay money, people can't buy, the company can't generate revenue, right? Like a shopping company, and they can't actually go to the checkout page, or because it's too slow, or there's a problem. That's what an SLA is in place for, to say what happens if this doesn't happen. So anyway, that's SRE land terminology. And here's Captain. So if you see here, it's got at the top, it's got kind of dev and staging. So there's your different environments. And at the bottom, it says bring your own tools. So that's it's the saying you can integrate Helm and Argo and Jenkins and Prometheus and other tools. But the main thing to highlight here is it says SLO score with a 97%. And so the key difference between Captain and other tools is Captain actually integrates with your your observability and monitoring tools, and it knows what that data means as well. So and it will integrate with New Relic, Datadog, Prometheus, and all the other stuff, which like a CD tool by its default doesn't. CD tools don't. Mostly they just deploy things, and they'll do what you tell them, but they won't make their own decisions, and they won't react to changes and do things for you, right? Or at least alert you when things are happening, and that's what Captain does. So here's an example of Captain. When the user on number 1 on the left, they push a change, like a new version of the app, then number 2 kicks in, number 3 updates some config, and then 4 is basically your kind of CI pipeline. It does kind of like adapt deploy, don't worry about that, but it's basically just, it does some, it isolates, it deploys it in an isolated area, and you can optionally run some tests against that, maybe some integration tests, API tests, user interface tests, right? And it can then pass those tests, and if it does, then number 6 is monitoring feedback. So let's say it was like you ran some user tests and checked the speed of the pages to see if the database queries are totally messed up or something like that. Now, if you're happy with number 6, then number 7 is it will update the branch on the GitOps repo to say, hey, we're going to update the production branch or the staging branch on that repo to change the versions of stuff that's there because we're promoting it as it's passed. And then ultimately, this is where continuous delivery solutions kick in, either Captain itself or Captain would trigger like Argo or Spinnaker or something like that, or Jenkins, and you would get your deployment happen. But you've got different deployment strategies available here. You've got blue green, you've got rolling update, you've got canary deployments, you've got all these different deployment choices you can have out of the box that just run. And so blue green will basically launch a new thing on the side. Let's say we're on production, so number 8, it will deploy the little green shape will basically, it'll be your app on the site, and it will maybe be alive for 30 seconds, and it will monitor the health checks, and it will have health checks in it to make sure it's healthy, and it can say talk to the DB, and it can talk to the caching server, and then the different deployment strategies you can configure to say allow like 1% of all traffic to hit this new service to test the waters a little bit for a grace period. And this is a lot of Kubernetes functionality that's built into Kubernetes, and you just tell it what you want. So this is kind of just it's just activating that deployment procedure basically. And what will happen is when the traffic's going through to that new service, whether you're drip feeding it down or you're doing AB or you're doing just all the traffic going to the new service, number 9, my point is number 9 is where it really changes the game. So Captain will actually look at your observability tooling in real time, like your New Relic, your Prometheus, or whatever, and you configure Captain about alerting and thresholds to say if my service, the CPU RAM is too high, it's spiking, you've got a problem with your code, obviously, then that's an alert. If the response time on the UI is too slow, or it hits a threshold, or something doesn't happen within a certain time, that's an alert. Now, the difference between Captain and other tools is when that alert threshold happens, you can tell it to either just notify you, like other tools will, or it can actually tell it to do stuff for you in real time. And so you can tell it to roll back. And so ultimately, number 9 is identifying whether that new service, the new version of your service, is healthy or not. And it could be after 30 seconds, it could be after 30 minutes this happens, right? And it will trigger a rollback automatically for you and take that bad new service out of the connection pool, and it will replace the old one. And so usually maybe the old one, because it's blue-green strategy, the old service will be sitting in the background, waiting to see if it needs to become the primary again, the master again, because the new one's obviously getting rolled back. And when it does so, this is kind of where GitOps number 10 kicks in, and it actually reverts a commit on the repo and reverts back to that and pushes back into the same repo. And again, and then Captain realizes this and it reacts and goes, okay, blah, blah, blah. Now production is getting the old version and then updates it in the fly, and bam. So this is just one use case example of like a scenario, right, where you can do things with Captain. But ultimately it's good at making decisions, and it's got tight integration into tools such as Datadog, Prometheus, and Dynatrace, and other things. And it can calculate SLOs. So it uses the SLO percentages in data to ensure you've got your uptime. But when you don't, it will tell you. Most importantly, it makes decisions. And for example, it will tell you if your software is allowed to go to the next environment, or it will block it and say no. I'll give an example. If you're doing a staging deployment or a pre-production deployment, and it monitors it looks at the monitoring stats and data, and it realizes that your response times have went really high, or the number of requests per second you're getting through is getting slow, or it's slowing down. It will actually identify that on the staging environment and go, actually, no, you can't go to production with this because we've got, there's a problem with it. And so it helps make decisions, and we'll call them quality gates, and it blocks that in the process. um, yeah. And the last point, I suppose, is just saying that Kubernetes does have autoscalers, right? You can tell Kubernetes, hey, if I've got 3 containers running and the CPU hits 90%, or there's a whatever, then add another container, and it scales up and down based on your traffic and your stuff. But Kubernetes doesn't really understand the bigger picture, and it just knows on primitive information. And so actually Captain can do the scaling for you. It can take over from Kubernetes autoscalers, and Captain can be the autoscaler, because again, Captain's smarter, and it integrates with your actual tooling, your monitoring tooling, and based on your SLO data that comes back, then it can make really good decisions around when to scale and how much, and all that. So that's another kind of USP of Captain. That's the kind of the end of the highlights, a few of the projects I've highlighted today. But ultimately, as a small recap, GitOps is driving us forward as a community into the distributed system space and the managing of that. So definitely check that out. More unopinionated tools are coming out, i.e. open source tools, and they're facilitating the journey to continuous delivery. And Argo CD specifically is driving us into the future with event-driven pipelines. I've got a little bit more than that on the future slides. And ultimately, the innovation of pipelines is occurring. And Captain being your control plane for all of the integration of the CI and CD and monitoring tools is under one hood. And there's Jenkins X CLI, which I'll talk about in a sec. And that's not actually Jenkins X. You'll see the difference. It's called Jenkins X CLI, but it's not Jenkins X. What else is happening now is we have these called SIGs. A SIG is a special interest group. This came from like the Linux Foundation and the CNCF Foundation and the Kubernetes ecosystem, where you've got different groups of people that are specifically interested in different areas like networking and security and integrations with tools and interoperability, other things like that. So the CDF, the CD Foundation, has 2 SIG groups. We have an interoperability group, which looks at how the different projects like Argo and Flux and all that, how we create stuff that you can create at once, and that thing will be able to just be dropped into any of the CD tools and just work. So rather than writing something in Jenkins syntax and then writing something in Bitbucket syntax and then GitHub syntax, for example, or in Flux syntax or in Argo syntax, you just write something once, and then each system understands as like a protocol, an interoperable way, how to understand what you built, and then it just runs. And you can just take your stuff with you between pipeline vendors, between projects, between companies. And so that's our that's the future of where we're kind of moving, where we're at today. We've also got the events SIG. So this is allowing CI/CD systems to talk to each other in an event, publishing an event. So it's about publishing events and listening for events, and allowing the different CD systems to be sort of event aware. And so if you've got one system, you don't have to refactor and bring it all the way across. You can just kind of have different areas of your organization use the right tools for the right job based on what's happening, right? And anyway, the point is, it's generic events is being like evaluated and considered across the different CD tools in the CNCF landscape. Now in 2020, 2021, and 2022, the innovation of pipelines is occurring, and that's fundamentally where we're shifting to. So we have changed our platform architecture from monolith to distributed systems, and then we've changed. Proprietary companies have came along, and then now we've got open source tooling that reflects and allows us to have tools and have procedures. But the next thing that's occurring now, and then we have GitOps, right, which is a way of working as well as an innovation. But now we have an innovation of pipelines, which is actually gets me really excited, because traditional pipelines were webhook based and they were monolithic focus, and it hadn't innovated much for in about 10 years or so at all, really, until the trigger of innovation occurred. Now these days we're still thinking we're using distributed systems, but we're still thinking in a monolithic sequential pipeline manner. Our minds are still there because the tools have changed, but as humans, our minds haven't changed so much until recently, and that's where things are starting to shift. So we're on the edge of reinventing pipelines as you know it into small, tiny pipelines that are linked together using events, which is an event-driven architecture. And so a big pipeline will no longer be a pipeline. We'll have little tiny mini pipelines, and those mini pipelines will be put together into things that we call workflows, like Argo workflows or Captain workflows, or whatever. And things can get reused, intersected, and they can publish events on and trigger things together. And so event-based pipeline architecture is what I call it, I suppose. This is a very common pattern the in the software engineering industry. We've taken that software engineering principles, and we're now bringing them into the sort of the CD space, continuous delivery space, and applying what we've learned in the software industry into this new innovative tools and processes now. And so pipelines will no longer deploy applications anymore. They'll trigger events, and then other things will listen to those events and then do their job. And those other events, like it could be like Argo or it could be Flux or something, that will listen for that event and it will pick that up and then it will do something. And then when it's done its job, it will publish another event and something else will take over. So kind of like how you've got serverless architecture these days on software, where it's not one big app, it's kind of like a Lambda function or a serverless function that triggers, which can call another function, or it can publish an event, which another function gets triggered from. So it's kind of serverless architecture mindset applied to pipelines. So they're cleaner, they're stateless, and we get good stuff, right? So this is where we're moving into this space. So event-based pipeline architectures is an example. Is you will push to a Docker image registry your new copy of your app, and you'll publish an event called like image published, right? And then something will listen and pick that up, and there'll be another pipeline that will do security scan of your Docker image. And then if that fails, then there'll be something that happens there. And if it passes, then there'll be something listening for that, which will then like security scan passed. And then there'll be a deploy and run tests, a deploy sort of pipeline that reacts to that and then it goes and deploys it. And then that will have its event, and then you kind of get the point, and then run tests will run tests against a production environment. Maybe it's load tests, maybe it's some smoke testing or something like that. And then when those tests pass, then it'll be an event listening for waiting for that, such as go and update the pull requests to mark them as, you can do stuff like, yes, this is passed, yes, this is deployed, and all that jazz. So again, still the same workflows, but more decoupled and maintainable and reusable and, all that good jazz. So that's the innovation of pipelines, and that's where you'll see in the next 12 months, if not beforehand, things moving in that pattern. Now, this is Jenkins Xci, which is one of the last tools I wanted to highlight. So Jenkins Xci is actually not Jenkins X. It's an embeddable tool that you can embed into any legacy system, any legacy pipeline, whether you've got a Jenkins pipeline or you've got Bitbucket or you get some Bamboo or you get something that's old, you don't want it there anymore. But you can't, there's so much technical debt or time and effort involved in refactoring that for the big bang approach to kind of refactor it all into kind of GitHub Actions or refactor it into a new pipeline system. And so using the strangler pattern, you can utilize the power of the new innovations in an easy way because Jenkins X has a plugin model, and Jenkins X has plugins for Argo and Flux and all these other things. And it's basically like you could call it on Bash, you could call it on the command line on Linux. So if you've got a Jenkins pipeline and it's got 10 steps, and one of those steps is like deploy, right? Well, you don't actually have you don't have to replace the whole pipeline. You can actually have a deployment sort of set up on the side, or running your test suite, right? Is using another dedicated tool, right? There's a tool managing that. So you can just actually delete the code from your old pipeline and put a Jenkins X CLI tool call in there and just execute the new guy. And so that new guy will kick in and do its job and come back. And so the pipeline, piece by piece, using the strangle pattern, you can replace parts of your legacy pipeline with to execute with just Jenkins X CLI calls and to call the new guys, and they'll do so. And over time, eventually, you'll have a new pipeline and new deployment processes, but you don't have to go big bang approach. And this is what I'm suggesting to people is to use this approach, and you can use this tool to help you get there and to kind of get into the future. That's all I have at the moment. I hope the slides and stuff was you could follow them along enough. And obviously questions, you can find me on Twitter, LinkedIn, and there's my email address. And if there is any questions or whatnot, then fair enough. If not, you can catch me on those places. And that's all for me. Thanks for listening.
Thank you so much. That was great. That was a really enjoyable talk. Thank you.
Cool.
Do we have any questions? Let's see.
I have a question. How do I see the chat?
How do you see the chat? You need to go and sign up for the event on the live orange art.
Okay, no, it's all good.
But there's no questions or anything, so
yeah, fair enough. That's fine.
So I guess we'll. Yeah, were you saying something?
I was going to ask you, where do you publish the slides?
If you give them to us, we'll share them on Twitter, and yeah, we can share them
on the meet. So yeah, for folks listening,
and
the
the
meetup
meetup
page. Yeah, we'll get a link there somehow.
Okay.
And and I'll put the slides there so people can. The style of my talks is it's more of an overview, and there's lots of information to take in, and you can just take from that on the slides and go and check out this tool yourself and do your own research. So we'll get the slides up on meetup.com and you can come back to stuff.
Yeah, definitely. We also have a Slack group chat, so we'll add them in there as well.
Cool.
So it'll be reachable from everywhere. Cool. So thank you very much for joining us, and we'll see you all on the June event.